Hello everyone and welcome to another tutorial video on our channel. In this video we are going to be talking about deep learning for Java and how to use it to build an AI that can play the snake game. So on the screen you can already see it. You can see the trained network that is playing the game. So this what we have here is a game currently being played by a network that was pre-trained by me, so using the code that I already have, so the code that I will be explaining in this tutorial. And as you can see, it has few parts. So we have this blue dot, which is basically the point or the food which snake needs to eat. We have the green part, that's like the tail of the snake. We have the red part in the middle, that's the head of the snake, and we have this light red squares. Those are just the fields that snake can see. So basically those are the places which snake can see. So one important thing about these neural networks and this what we have here is number of inputs. So these things that the snake can see, those are our inputs. This is what the snake knows about, but more about that later. So the first thing that we want to see is how you can get from a completely new snake that can't do anything to something like this. This one is really not perfect. It will not finish the game, but it will come to a certain amount of points. I think the highest one I saw was at 100 points or something with only 4 inputs. That's really good. So let's start from the beginning. Let's see how we can actually build the game. So without neural networks or anything, just the game that a player normally could play. And then let's see how we can train the network to play that game and how we can use the trained network to let it run the game. So let's start from the beginning. Let's see how we can build this kind of a game. So in order to build this game, we created a new class called game. It extends this J panel and implements this action listener, which we are going to be taking a look later on. We have some logging mechanism so that we can just log some nice messages, and we have all of our images loaded in. So this game util, which is by the way here in this util package, can load us all of the images that we need. So it's nothing special. We're just creating this image icon based on the image that we have in our resources folder, and we are just loading it in. Here also we have the game dimensions, which are 300 by 300, and we have a player size which is 10. Besides that, we have an array of positions. So this position is just a helper class which contains the X and the Y coordinate for that position. It can be like a snake position, so the position of the head, position of the body, or just the food position and stuff like that. And we also, in addition, have some helper methods here, for example, to tell us if the position is outside of the game bounds. For example, our game is 300 by 300. If you would have a position that's at, I don't know, 50 by 450, that's outside of the game bounds, for example, then you know that your snake went outside and it should die. We also have this equals method here, and toString to print it out nicely. So nothing special about this one. The next thing that we have is this direction helper class, which is just an enum, which contains a couple of directions that the player can have, so the snake can have. So up, right, down, and left. So this is something that we're going to be using later on. And you can see that the current direction indicates what's the current direction of the game, of the snake. So currently the snake will start going right as soon as we spawn in. And we also have the flag to indicate if we are currently in the game or not. So in-game true means that the game is running. If this is set to false, that means the snake had died and we are not currently running the game. This is important for the neural network to know when it needs to take a reset the game state, basically. We have also a position for the food position. So this is where the food position will spawn. And we have a snake length so that we can track how many points the snake has, so how long is the body, basically. And in the setup we have a couple of things to set up our size and all of that nice stuff. And we have this initialize game method. So in it we are setting our snake length to 3, because at the beginning we have the head and 2 parts of the tail, so we have 3. We have the snake position array reset it, and we also set the snake on its default position, so we know that we want to start from some position, and we are just setting it there. And now also we're using this set food position, which is just giving us some random position somewhere, and we are setting it as a food position. And if the food position equals head position, then we do not want to, we want to create it again because we don't want to set it onto the snake. Actually, this might be wrong here, what we have. Actually, that is a bug. What we want to do here is exactly this thing, but we want to say that we do not want to food to spawn on the snake itself. So what we need to do is we say arrays dot stream snake position. So snake position is our array that contains all of our positions of the snake, including the head. Dot contains actually not stream as list contains food position. Basically, if this snake position array contains the food position, we want to reset it. That's just to prevent the snake to spawn on the, so to prevent the food to spawn on the position where the snake body is, because that should not be allowed. Okay, let's go back. We also indicated the game is in true, and we use this build state observation. So state observation is the first thing that we have that's needed for our neural network. For the game itself, we don't need it. If you would be playing it on your own, you wouldn't need it, but this is something for your neural network. So these are our inputs basically. So let's take a look at this game state class that we have. So this game state contains this array of inputs, which is of type double, and we have a couple of methods. We have a toArray method, and this is skipped method. Get data, which is creating this DQN4j array, and also this get matrix array, which basically creates a matrix of these inputs that we have. And this is all coming from this class, so this interface. So as soon as we implement this, we need to override these methods and implement them. This is needed for your network, and we'll see later when we are using it. But for now, let's talk about this. So these are our inputs. This is what I was talking about. The snake can see 4 things. For example, you have its head. It can see in direction up, it can see left, it can see right, and it can see down. So this is something that we are building here. What we are saying here, we have the snake position, we have the food position, and we have a direction that we are currently taking a look. So if we jump to this, get state for direction, basically this will return a double value, meaning it will be -1, 1, or 0. So we take the head, we get the next position. So we have the direction, for example, in the first one, it's direction up. If we have a head at a certain position, the next one is directly one above it. And if we would have left, it's the left one, it's the right one, it's the bottom one. So those 4 states. And the next position is we are checking if the head is unable to move to the next position. That would be, for example, imagine that the snake is in here, in this corner. So the head is, for example, here. The next position is up, and it can't go up because, it's the end of the map. We can know that. And it could not also go left. It could only go right, and it couldn't go down because the down is the body of the snake. So it could only go right. So this is a state. When we would build these inputs, we would have -1 here. We would have 1 here maybe. We would have -1 here and -1 here, because we can't go here, we can't go there, we can't go down because the body is down, we can only go right. And this is something that we are building here. We're building these inputs so that the neural network knows for all of different states that we have. So depending where the snake is, depending where the food is, we get different states. So if you can go to the next position, if you actually can't go to the next position, we immediately return -1. Now we have this direction to check. We are checking where the food is. If we are checking up, if the head position Y is bigger than the food position Y, that means that we are moving in direction of the food, and we return 1. And otherwise we just return null. Same is for the right, down, and left. So nothing special here is happening. So keep in mind that if you would have, imagine you have an axis like this and like this. So this would be your Y and this would be your X. Here you would have 0x, 300x, you would have 0y here and 300y here. So keep in mind with that when we are building these states for directions. And I forgot to mention, you also have this game state test, which you can then play with and see how all of this works out. So just so that you know that it's doing the correct things that you want. Okay, let's go back. Where were we? No, here we were at the game. We were building the state observation and we were looking at this initialize game. So let's move back to here. So we were in the constructor of the game. So that was the thing that we want to do. We have this action performed method. So this is something that we are going to be calling manually every time we move a player. So every time we move a snake, we want to say that some action was performed. Usually this would be triggered by some events, for example, if you would press a key or something, but we are now not pressing the key, so the computer, so the neural network is playing for us. So we need to manually call this. Basically what we are doing here is we're checking if the game is ongoing. This is just checking this in-game flag that we talked about. And we are checking if the food was eaten, meaning that if your snake moves from one position to another one, we are checking if the food position now equals the head position. If it is equals, that means that we have eaten the food and we can increase the length of the snake. And we can also set the new food position. So basically we just respawn the food. And if the food was not eaten, we are again checking where the head is. Could the head be outside of the bounds? If that's true, then we just set that the in-game is false, meaning that the game has ended. And if the game is still running, we're checking if we are colliding with some other part of the body. For example, if we are colliding, the head is colliding with some part of the tail. Basically what we are doing here is similar to that bug that we just fixed. Is we are streaming through these snake positions and filtering how many head positions there are. There should always be one head position, and basically that's something that we are checking here. So if there is more than one head position, that means that the head and some other position of the body matches, and that means we can just end the game. And yeah, the snake positions contain all of the possible positions of the snake, including the head. So keep that in mind. And the head position is always at the first place. So this array, so the 0 index is the head, always. Yeah, and after all of this, here we just have a log message, and here we repaint so that the component is repainted, and basically this will in turn call this method, and we have our draw method here. So we're passing in the graphics object, and in draw we're just checking if the game is ongoing. If it's not, we're just returning. So what we're doing here is we are drawing the food. So we have the food image and we have the food position, the X and the Y, and we are just drawing it. Then we are drawing the snake. We are going through the snake length, so how many points basically we have currently, and we are taking all of the positions. And here we're just checking because this array can have null values. For example, we have this 900 positions, and if the snake length is 3, that means that a lot of them will be null, so we just continue here. And then here we are just drawing if the index is 0, we are drawing the head, otherwise we are drawing the tail on this position. And in addition, so this is the last thing that we do, is we just take these observations. So basically this is, we're taking the network util, so the number of inputs, which is 4. So this is something that we defined, and we're just drawing all 4 observations that we have. So these are just the next positions from the head. So this is something that you can see. The head is this red square, and the observations, so these observations here are these light red squares. So they are not affecting the gameplay at all. So they are just something that we draw to visualize easier what the snake can see. So the snake currently only knows about these light red states. So basically it just knows what's there, nothing else. So this is what the snake can see. And we're just drawing that out here. Here there's a method to set food position. We saw that, and this is the bug that we fixed. Here is just a check if the food has been eaten. And this is the other check that we talked about, and this is the helper method to get the head position. I think that's pretty much it. Let's take a look at what we have here. We have the direction, we have the position, we took a look at that. We have the game util, we took a look at that already. We have the position util. So the position util just contains some helper methods to check if, for example, we have a method to get the next position, we talked about that one. This is just building a position on a certain place, and is position closer to the food position. Basically, this is something that we also want to check when we are calculating the reward. So if you move from one position to another one, you want to check if you're moving closer to the food. If yes, that means it's a good thing. Otherwise, it's a bad thing. So just keep in mind that we have this method here. For more details, you can just take a look at how to implement it. It may sound a bit complicated, but trust me, it's not. So the gameplay, so the game implementation itself is quite simple. And in addition, we have this reward util. So this is something that we use to calculate the reward. So every action that we take when we are training our network should give us some reward. So for example, imagine that you're here, and if you move towards the food, that's better than moving away from the food. So the bigger the reward means that the snake is doing something good, and that's how it learns. So it, depending on the state it has, for example, it knows that it's here, there is nothing around it, and it goes left, oh, that's good, it goes right, that's bad. So it learns based on that. So this is one thing that we are using. So we are using this to calculate the reward. We know what the next direction is, and we know what the next position is, and we get the reward for that position. Of course, the rewards can be tweaked. So for example, here, if the next position is outside of the game bounds, meaning that the player will die. So if we are here and the snake decides it wants to go up, that means it will die, and the reward for that is -100. But if it goes left, and for example left is food, that's 100. And if it moves closer to the food, that's just 1. And if it moves away from the food, that's -1. You can play with the rewards, and basically if you tweak them around, the snake behaves differently. Yeah, so that's everything about rewards, everything about positions. We took a look at the game, and now we can take a look at our network itself. So let's take a look at this network util. So this is a util class that we use to build all of our configurations and the actual network itself. We have a number of inputs defined here. So this is something that we have hard-coded for. This is something that you can change. You can increase the number of inputs, but you also have to make sure that in the game where we are building the game state, I'm not sure how is it called. Yeah, build state observation method. Here are 4 inputs. You need to provide more of them. So if you say I have 5, 10, 15 inputs, for example, you can see that we are seeing here in direction up only 1 position. So there is only this 1 light square. Light red square. Maybe you want to see 5 positions. That's definitely possible. So your neural network has more inputs. You extend this. You have to get basically here, instead of the next position, you have to get the next position of this next position, and so on. So like more and more. And you can also do those closer positions, so like full circle around the head. That's also something that's possible. You should, if you want to, you can try it out. So you just give it a try and see how it goes. Number of inputs. Low value, this is those values that we talked about for our inputs. It can be -1, and the high value is 1. So it can go from -1 to 1. If you have more inputs, maybe you want to change that. Maybe you want to have different values. It's really up to you. So, and we have our configuration. I will not be talking much about it. It's really a copy paste from their website. You can see all of these parameters, what they do, explained there. So they have a really nice documentation. You can just go through it and see how it, looks like. Same here, we are building this DQN factory, which is used then basically to build our network based on the configuration we have. Again, all of these can be seen on their website. So just take a look at what all of these parameters do. And we have this load network. Helper method, basically we just use to load the already trained network. Nothing special here. And we have a wait method. This is basically just a busy wait we can use. I'm using it here when we are evaluating the network, just to make things slower. Usually it would be very fast and you couldn't see what the snake is doing. This is really nice for debugging, because then you can take a look at what the snake is doing and you can evaluate it a bit better and see what's the good thing and what's not the good thing and stuff like that. Yeah, so that's the network util. Game state util, I think we already took a look at this. Yeah, we did. So this is a game state for direction, how we build a game state for one direction. We talked about this. There is a max value index. Basically, you give it a list of values and you're trying to find the index of the max value in this array, so nothing special. And is head unable to move to the next position? Yeah, we're just checking if the head will be out of the bounds or it will be colliding with the body. So nothing special here. Then let's take a look at action. So action is, we have some unused imports here, let's get rid of them. So the action is what the player can do. Player can move up, can move right, can go down, and could go left. So this is something that you also define when you're creating your environment. We'll be talking about that later. So we have 4 actions. Player can only do that, so that's the game. You mean you can't have much actions. You can't just not do anything. You always have to move somewhere. And yeah, so here we just have list of actions. So we are just using this values list as a list of actions. We have some size, some random, because we can also get a random action. We also have get action by index, so that it's a helper method to get the action by certain index. We're using that, and get the action index. This one and this one are not used. We can actually get rid of them. We don't need them. And yeah, let's take a look at the game observation space first. So game observation space is basically what the snake can observe. It's just this helper object that's used by the neural network when it's training, and you need to provide different things like this shape. This is important. Basically what you're saying here is the shape is 1 out of number of inputs, and we have 4 inputs because we saw that our game state can have 4 inputs. And this is something that we're using here. We're saying 1 out of 4, and then we have this what's the lowest value of the input. We saw it, it's -1, and here its highest is 1. And we also have this method to create this values array. So basically just creating these arrays here, nothing special. So these are the low value and the high value is just below it. So nothing special, we just have to implement all of these methods from the observation space. Game state, yeah, we took a look at that, we took a look at that, we took a look at this, and environment. So this is where the magic happens. We have this environment class which implements this MDP. This is all from the reinforced learning for Java package. We are implementing this and providing its game state. So if you take a look at here, we have the observation, which is our game state. We have the action space. And this is what we have here. So we have our game state, the integer is the action, and discrete space is what we are using as our action space. And here the size is 4 because we have 4 actions. We also, whenever this is created, we are creating a new instance of the game itself. We get the observation space. We're using our game observation space class that we just saw previously. Yeah, the action space is this one. And reset method, we are using the initialize game one from the game that we implemented. So basically this was reinitialize our snake and put it on a fixed position, but also it needs to return the game state. That's why we are returning it here. Otherwise you wouldn't need it. It's just needed for the network. This one is not implemented. We don't have to do anything. And this step is the one that's important. For every step, we'll call it with some integer. So this is a value of an index, of an action index, meaning it goes from 0 to 4 because we have 4 actions. It knows about it. And based on that, we take an action to take. And then we are calling game change direction. So if we jump here, you can see that we call it some action, and based on the action, so if it's move up, we change the current direction to up. If it's move right, we change it to right. But we also have these checks. For example, if it's move up and the current direction is down, the snake can't go up. So this is something that's limited by the game snake. For example, it's moving up and you say down, you can't go immediately down. That's not possible. So the game doesn't take that input. It just doesn't do anything. And that's why we just return. So we don't change the direction. Then we're calling game move, which basically will move the player. So it will copy all of the positions that we have in the snake position, meaning head is at blah blah position. Now the tail will be at that position. And whatever was the tail, position 1 will be now at the tail position 2, and tail position 2 will be tail position 3, and so on. And then we'll take the previous head position, which is now currently at the snake positions 1, and we'll set it at the snake position 0. So we will create a next position based on the current direction, and then we'll call this action performed. So to do all of these checks and repaint. Yes, so after the move we have the wait, which is at 0, so we just don't wait here, so it's training is faster. And based on the action that we just took, we calculate the reward. We saw this method, so this is calling this reward util to calculate the reward for the action that we just took. And after that we build the current, or we get the current observation, and we create this step reply, and we provided observation, we provided the reward, and is done basically checking if the game is still ongoing or not. And yeah, that's it. Here we just have the, when we're creating a new instance, it just creates the new instance with the game. So nothing special. Not sure if we need to do something here. Maybe we could. We could call game initialize game, so that the game is reinitialized every time this environment is created. So this is one thing that we could do. Okay, so now we have all of this. How do we actually start training? So that's in our main class. So we have here, we're creating some random name. So here we're just creating the game itself and all of the the title and that stuff. So this is not related to the network, it's just the instance of the game is created here. This is something that we need. We're creating this in a new thread here, so we are running everything in a thread here, nothing special. We are creating a random network name, we're creating our environment, and we are creating this DQL object based on all of the network util stuff that we saw. So the DQN factory and the configuration, and we are providing the environment here. And this is basically creating this discrete dense Q-learning space thingy, which you can then use to start training. We are calling this close also, which will not do anything because we didn't implement it. And after it has done training, it will save the network. Basically, it will use the random name that we used, and we will save it. And then we reset the game and we run the evaluation. So this is something that we're doing. So you can see here that this zip file here, this is a train network that you can use. And if you would just play this, so if you would go here and start this, it will train a new network and then evaluate it. If you just want to evaluate the current one, just copy this name, paste it in here, and comment out basically this part here. And then you can just evaluate it without training. So this is just a thing. And evaluation is basically loading the network based on the name, and then just iterating a certain number of times through it. I have here 1000, which we are probably not want, maybe 10 is enough. And we are going 10 times, we have the score. While the game is ongoing, we're getting the current game state and getting the output from the network. So we're saying this is the state, give me an action which I should take. So it gives you this output, and based off this data, which is basically an array of doubles, we get the index of the highest one. So we have 4 of them, and we get the index of the highest one, and basically this is our action. And we are changing the direction based on this action, again moving and incrementing the score after we have moved. So yeah, it's just the score is snake length -3 because we start with the 3 points. So yeah, nothing special here. And we here wait so that we can see it. So basically this is what's happening currently here. And yeah, that's pretty much it. Afterwards we just reinitialize the game. Nothing special. Hopefully you liked it and you enjoyed this tutorial. If you have any questions, do let me know. And here you can see the results of the already trained networks. So these are the iterations, and these are the how many times did the snake eat the food. So here you can see 35, for example, that's okay. Here we have 40, 43. Actually, let's see what we have. We have 0 actually. Here we have 53. What else do we have? Yeah, that's it. So 53 is the highest one currently. Maybe it's at iteration 48 and it goes up to 1000, so maybe it will eat a bit more. One thing that you can see that it has problems with, so I've noticed that it gets tangled in itself. That's because it doesn't see that far. So this is like a homework for you. If you want to implement it, you can increase the number of inputs. So the further away the snake can see, the better it is. But that requires more training and stuff like that. I just wanted to build you a video on and show you how you can do this, and then you can just tweak the inputs, tweak the rewards and all of that stuff, and then you can see if the snake can behave a bit better or not. But yeah, basically this is what you have here. Hopefully you liked it. Before I built this snake, I tried it with just a square that was about to go and eat food. So there were no obstacles except this corner. So if it would go outside, it would die. So that was the entire game, and it went up to 50,000 points because yeah, it was just knew what it needs to do. It would always move towards the food, and it was actually quite amazing. And I just had to stop it so it would never basically die. It would go as many points as it can. So yeah, so if you have any questions, leave them in a comment, and if you like this video, consider subscribing to my channels for more exciting videos like this. And I guess I will see you in the next one.